Hello students, today's lesson is on applications in writing linear equations. We're going to start by putting a great focus on writing the equation. So we are going to write the equation of the straight line. And after we're good at writing equations, then toward the end of the lesson we'll do a few applications. There are two ways to write an equation, a linear equation. One is using the point-slope formula, which you can see here is y minus y1 equaling m times x minus x1. The other method of writing a linear equation is the slope-intercept form. And this is the form that I use most frequently, and I think it's a little bit easier. So when we go into examples, at first I will do both methods, which is going to be kind of time-consuming, and then I'll move off of both methods and move down to the one method that I use most frequently, which is the slope-intercept form. Now, to write the equation of a line, you have to have two things. You have to have a point, and you have to have the slope. Regardless of which of the two methods you choose, you must have those two pieces of information. In this first example, it says write the equation of a line which passes through the point negative 4, 2 and the slope of 2. So we're given the point and the slope. Alright, so there are two methods. I'm going to go in and I'm going to do the method y equaling mx plus b first, and then I will use the other method, the point-slope form. Okay, we know the slope is 2 and slope is m, so this becomes y equaling 2x plus b. At this point, we're very close to already having the equation, so I'm not going to completely square this off, but I'm going to put a dashed line around it so I realize that I'm close. Now, I'm missing the value for b, which is the number on the end, the y-intercept. So in order to do that, to find that b value, I now turn to the given point, negative 4, 2. So the given point, x is negative 4 and y is 2. So I replace the y with the 2 and the x with the negative 4, and when I do, the only value remaining, the only variable here is b. So 2 equals negative 8 plus b, and when I add 8 to each side, I have the b value. So now I return to this box, which I had in dashed box, and now I know what the answer is. The equation is y equaling 2x plus 10. That is the linear equation. That is the equation of the line passing through the point negative 4, 2 with a slope of 2. Now the second method, which is going to give me the same result, the second method was the y minus y1 equaling m times x minus x1, which is the point-slope formula, which will result in that same equation. So I start off the same way. I start by replacing the m with the value given of 2. Okay, so I replace the m. Now I use that point, negative 4, 2, for the x and the y. Now in this case, x sub 1 is the negative 4 and y sub 1 is the 2. So this becomes y minus y sub 1, which is 2, equaling 2 times x minus a negative 4. Now be certain to catch the minus the negative number. So this becomes y minus 2 equaling 2 times x plus 4. Now if I distribute the 2 on the right side, it becomes 2x plus 8. And then when I add 2 to each side, I result in the same linear equation. Okay, so that's both methods. The method on the left is a little shorter, which is probably why I tend to use it. Now it does ask me to graph this line, and of course there are many ways to do this. I can just graph the point they gave me and the slope they gave me, but I can also use my slope-intercept form, whichever one's easier. If I want to look at the slope-intercept form, I know this number on the end. Now remember, this is y equaling mx plus b form. So my y-intercept is 0, 10, and my slope is 2. So if I want to use the slope of 2, I would rewrite this as 2 over 1, which is my rise over my run. So if I plot the point 0, 10 up here on this piece of graph paper, I go up 2 and over 1, there's a second point. That would give me the linear graph. There it is. Okay, so there's how you write the equation and it's graphed. So here's another one. Write the equation. And remember, the goal here is to write the equation. Write the equation of the line passing through this point, check, and this slope, check. So it's ready to go. So if I use y equaling mx plus b, and remember there's two forms, I can use either one of these methods, the slope-intercept form or the point-slope form. I can use either one of these methods to come up with the equation of this line. Alright, that gave me a slope of a negative 2/3, and that's the first thing I use as I put that slope value in. And at this point I note that I almost have the answer. I just need to find b. So now I go back and use the 0.50. I replace the y with 0 and the x with 5. So this becomes 0 equaling a negative 10/3 plus b. And then when I add 10/3 to each side of the equation, my b is 10/3. So now my equation, taking this 10/3 and placing it back into my box, where my answer is, I have y equaling a negative 2/3 x plus 10/3. There's my equation. Okay, now if I use the second method, I do the same thing by beginning by substituting in the slope value, which is a negative 2/3. And then I replace the x sub 1 and the y sub 1 with the point in which x sub 1 is 5 and y sub 1 is 0. So this becomes y minus 0 equaling a negative 2/3 times x minus 5. Well, y minus 0 is y. And if I distribute the negative 2/3, I get a negative 2/3 x plus 10/3. Again, here's my equation. Alright, 10/3 is not a really fun number to play with on my piece of graph paper. So to be honest, to graph it, I think I would go back to the two pieces of information they gave me and I'd plot the 0.50 and use the slope negative 2/3. Let's plot the 0.50, 1, 2, 3, 4, 5. And given that my slope is a negative 2/3, which is my rise over my run, instead of rising 2, because the 2 is negative, I have to drop 2. So I'm going to go down 1, 2, and then to the right, 1, 2, 3 to get another point. Okay, so there's my 2 points. And my line will look something like this. I mean, I'm freehanding it on a tablet, so it doesn't look really good, but there it is. Another one, write the equation. The whole focus of this section is to write the equation and then apply it. Okay, so write the equation of the line passing through 2 points. Now remember, we have to have two things. We have to have the slope and we have to have a point. They've given me 2 points, but I do not have the slope. So pick a point. I think I would pick the one that has the fewest number of negatives in it to use when I'm ready to write my equation, but now I have to find slope. So to find my slope, this is my x sub 1, y sub 1, and I guess this will be my x sub 2, y sub 2. So my slope will be y sub 2 minus y sub 1 over x sub 2 minus x sub 1. So this becomes 1 plus 4 over a negative 2 plus 1. So my slope is negative 5. So now I have my slope is negative 5 and I have a point. So now I'm ready to write my equation. So if I use y equaling mx plus b to write my equation, I start by substituting the negative 5 in place of my m. This is almost the answer. Now, to get b, I use the point negative 2, 1, replacing the x with the negative 2 and the y with 1. Then I get 1 equaling a positive 10 plus b, and when you subtract 10 from each side, your b value is 9. So now your equation is y equaling a negative 5x minus 9. There it is. And so they want me to graph it. I mean, you could graph it using your slope and your y-intercept, knowing that your slope is negative 5 and your y-intercept is negative 9. You could do that. but that's going to be off my graph because I've only 5 to 5. But you know, I could do the easiest thing, which is just take the 2 points they gave me and graph it. So -1, -4 is here, and -2, +1 is here, and here's the graph. There it is. It would go through 0, -9, way down here, and a slope of -5. Alright. Special cases. Remembering special cases of lines. Horizontal lines are lines that have only the y variable, and vertical lines are lines that have only the x variable. So if they said y equals -4, then that means that my y value will always be -4 regardless of what x is. So x could be any value, and so you could plot these points: 0, -4, 1, -4, 2, -4, 3, -4, and you would be reminded immediately that that is the graph of a horizontal line. If we want a vertical line, we pick x to be some number. Maybe x is 3. If I wanted to draw a table, my x value would always be 3. And since there is no y in the equation, y can be any value it wants to be. So I'm just going to make up some numbers. So if I plot the point 3, 0, 3, 1, 3, 2, and 3, 3, it confirms that when you have an x equals equation, your line will be a vertical line. So this says write the linear equation of the line which passes through the point 2, 3 and has a slope which is undefined in part A. And then part B says write the linear equation of the line which passes through 2, 3 and has a slope of 0. Okay, part A. Part A says I have the point 2, 3, and it says that my slope is undefined. Now we learned from the last section that if the slope is undefined, it is a vertical line. Okay, so the point 2, 3 is right here, and part A would have this graph of vertical line. Now, does it want the equation? Yep, it does. It says write the equation. If it's a vertical line, it's an x equals equation, and it will be x equal to the x value of the point it is passing through. Part B. It says write the linear equation of the line which passes through point 2, 3. It's going through the same point, 2, 3, but this one has a slope of 0. So it's going through the point 2, 3, and its slope is 0. Well, a slope of 0 is the horizontal line. And if it's a horizontal line, we know it must be a y equals equation. And if it's a y variable, then it's going to be y equal to the y value in the ordered pair. So there's the answers to both of those situations. X equals is a vertical line, y equals is a horizontal. Okay, determine the slopes of parallel and perpendicular lines. Parallel lines, of course, will have slopes which are the same, which means the slant of the line is identical. Perpendicular lines will have slopes which are negative reciprocals. It's a two-step process. You take the negative and you take the reciprocal. So if you have a slope of -3/8, a parallel line will also have the slope of a -3/8. A perpendicular line says change the sign, so if that one was negative, this one's positive, and take the reciprocal. It's a two-step process. Change the sign and take the reciprocal. Part B, if your line is parallel, then your slope would be 20. If it's perpendicular, what is it? Well, this can be rewritten as a positive 20 over 1. So perpendicular slope, and we usually put a little upside down T for perpendicular. Perpendicular slope, if this one's positive, perpendicular would be negative, and then you take the reciprocal. Ooh, see, it's a little tricky. If your slope of your line is parallel to the one with a slope of 0, your slope is 0 also. What if you're perpendicular? Okay. This is 0 over 1, and it's positive. So your perpendicular would be -1 over 0? That does not work. That is undefined. And guess what? The slope of the perpendicular line will be undefined. Because remember, if your slope is 0, it is a horizontal line. So if you're perpendicular to a horizontal line, you have a vertical line. And if you have a vertical line, your slope is undefined. Okay. Are the given lines equations of lines which are parallel, perpendicular, or neither? Okay. So they've given me two equations. I don't have a graph. It says look at these equations and tell me, are these two lines parallel? Are they perpendicular, or are they not parallel or perpendicular? To do that, I have to define the slope. Well, in the second one, this is real easy. You know the slope of the second equation here is 3. That's a done deal. The top equation I'm not so sure about because it's not in the y equals mx plus b form. But if I add 3x to each side of this equation, then the top equation will become y equaling 3x plus 7. So you have your two lines now, both in correct form, slope-intercept form. The slope of the top line is 3 and the slope of the bottom line is 3. So since they have equal slope, these two lines are parallel. Okay, part B, these are all out of order. This one's a big mess. Okay, now in part 3, or part B, again I need to solve for y. Now the top equation is a negative 1/3 in front of the y, so the easiest thing to do with the top equation would be to multiply every term times negative 3. Because that would clear the fraction and it would cause y to be isolated. If you do that, this equation becomes positive 1y equaling a negative 9x minus 15. And it is in slope-intercept form, and the slope is negative 9. The bottom equation has a few more problems. First of all, it doesn't say y equals at all. So the first thing I need to do is I need to move the 1/4 x. Well, I could clear fractions first. I'll clear the fractions. Let me clear the fractions. Okay. Let me clear your fractions. If the fractions are going to be cleared, then I would need to multiply every term times 4. When I do that, the equation is going to become 1x plus 8y equaling 24. Now, to solve it for y, I have to subtract x from each side of this equation. So then I would get 8y equaling a negative x plus 24. Then I would need to divide everything by 8. So I would get y equaling a negative 1/8 x plus 3. So my bottom equation is y equaling a negative 1/8 x plus 3. So the slope of the top line is negative 9, and the slope of the bottom line is a negative 1/8. They're not reciprocals of each other. First of all, they're not opposite in sign. One would have to be positive, and one would have to be negative, period, for them to be perpendicular. So I guarantee you they're not perpendicular. And they're not the same, so they're not parallel. So this one is neither parallel nor perpendicular. Alright, that's what it means. Give the equation of a line that passes through this point and is parallel to this line on the end. Okay, remember I have to have a point and a slope. Here's the point. I don't have the slope. I've got to pull my slope from this other equation because I'm parallel to this other line. Well, if I add 3x to each side of this given equation, then this line is y equaling 3x plus 4, and it has a slope of 3. The line I need to write the equation for is parallel to that one, so my slope must also be 3. So now to write the equation, I have the point negative 1, 2, and I have a slope of 3. So I use y equaling mx plus b, y equaling 3x plus b, and all I need to do is find the value for b. Alright, use my point negative 1, 2. Replace the y value with the 2, and the x value with the -1. So 2 equals -3 plus b, and when you add 3 to each side, b equals 5. So your equation is y equaling 3x plus 5. Give the equation of a line that passes through the point 68 and is perpendicular to this other line. Okay, so to write an equation, I need a point, have it, and I need a slope I don't have. But I'm going to pull my slope from this other equation. Well, to find the slope of this other equation here on the end, it must say y equals, so I know the slope is the coefficient of the x variable. So I need to move the 5x to the other side of this equation. So I have 2y equaling a -5x plus 10. Now remember, it has to say y equals to pull the slope off the equation. So I need to divide everything by 2. So I get y equaling a -5/2 x plus 5. Now that the equation says y equals, my slope is the -5/2. Now, my question is, give the equation of a line that passes through point 68 and is perpendicular to this line. If I'm perpendicular, if this one's negative, mine is positive, and I take the reciprocal. So the equation I'm supposed to write is passing through the point 68, and it has a slope of 2/5. No longer do I need the information, the scratch work over on the right side of the page. I focus only on these two pieces of information. I'm going to write the equation by using mx plus b. I replace the m with the 2/5. This is almost the answer. I just need to find the b on the end. Alright, so now I replace the y with the 8 and the x with the 6. So this becomes 8 equaling 2/5 times 6 plus b. 8 equals 12/5 plus b. I've got to subtract fifths, 12/5. Okay, so in other words, 8 minus 12/5 equals b. What in the world is 8 minus 12/5? 8 minus 12/5. Okay, this would be 40/5 minus 12/5. So this would be 28/5. So 28/5 equals b. So up here now the answer is y equals 2/5 x plus 28/5. This is write the equation in slope-intercept form. Oh, that's in slope-intercept form and also in standard form. Okay, so this is your slope-intercept form. And to get it in standard form, the x's are first, and then the y's, and then the equal, and then the number. So I need to move to get the standard form. I need to move this x to the front by subtracting it. So now it's a -2/5 x plus y equaling 28/5. Now that's standard form, but normally they don't like it to start with a negative number. They don't want this coefficient of x to be negative, and they don't like these fractions. So what I suggest you do is multiply everything times -5. That will eliminate the fraction, and it'll make the first term positive. So when you do this, you'll have positive 10/5 x, which is 2x, minus 5y equaling a -28. This is the standard form of the equation. 2x minus 5y equals a -28. X's, then y's, then equal, then the number. Find the equation of a line that passes through point 2, 3 and is parallel to y equaling 6. Okay, if it's parallel to y equaling 6, y equaling 6 is up here somewhere like this. If it's parallel to that, then it's also going to be a horizontal line. And every horizontal line is a y equals equation. Now, if it's a horizontal line passing through the point 27, then its equation, y equals, has to be y equaling the y value of the point it is passing through. Find the equation of a line that passes through the point 27 and is perpendicular to y equaling 6. Okay. So, going back to my rough sketch here, if this is y equaling 6, and this is the point 27, and I'm perpendicular, then that would be a vertical line passing through the point 27. So if it's a vertical line, it has to be an x equals equation. If it's an x equals equation, it's going to equal the x value in the point that it is passing through. So it will be x equaling 2. Alright, so here comes some applications. And I think I'm going to pause this video and start a new one because this is a long recording. So I'm going to go ahead and stop this one and I will start a new recording for the remainder of this lesson.